Okay, so let's take up question number 3, factors. This says, write a program that will display the factors of n, where n is a number provided by the user. So if we give the number 12 as an example, we say 1, 2, 3, 4, 6, and 12, because those are all factors of 12. Why is 5 not listed there? 5 isn't a factor of 12. Is 7, 8, 9, 10. None of those are factors of 12. So if the example was 10, what should we have there? 1, 2, 5, and 10. Right? Those would be the factors of 10. So this is the problem we're going to do. Okay. Now, what you want to start with when you're problem solving is, this is a computer class. But so we like to use computers, but we also use paper and pencil, and it's really important, and hopefully you used it yesterday during the quiz. And I bet the people who used it on the quiz, this is my paper and my pencil, by the way. I bet the people who used paper and pencil on the quiz yesterday did better than the people who didn't use paper and pencil. That's my bet. Okay. And I have a lot of data points over 16 years of teaching that tell me that that's the case. People who have the paper by them with the pencil when they're programming are much better programmers. The people who just sit there and hope that the answer somehow comes magically through the keyboard, those are not the good programmers. Get that pencil, paper out. All right, so we take the number like 12 and we think, well, we know what the factors of 12 are, but how do we instruct the computer to know? So this is how we always use an example. So this is an example, right? Always want to use an example when you're working through the thing. So we'll say let n, which is the input, let n be 12. So we're using 12 as an example. So now, if we were doing this in a very methodical way, which is how you have to explain things to a computer, remember the computer's dumb, so you must explain things to a computer in a step-by-step fashion. So what would I do? I would check all the numbers from 1 to 12, right? So let's list all the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why from 1 to 12? Why do I stop at 12? Why don't I check 13, 14, 15? Yeah. Good. Once you hit 13, any number greater than 12 cannot be a factor of 12. Do you agree? So you use some knowledge there to be like, okay, I'm going to start at 1, stop at 12, where 12 is your end. So keep that in mind. You're also just doing a lot of substitution, right, in programming. You're going to substitute numbers for variables when you're trying to figure it out, and then put the variables back in when you figured it out for the general case. So now you go, okay, let's start with 1. And now I'm going to have like a screen here. Right, this is my screen where I'm going to display, because it's asking me to display the factors. So this is my screen. All right, so is 1 a factor of 12?
Yes, sir.
Yes, so I display it. Is 2 a factor of 12?
Yes, sir.
Yes. Is 3 a factor of 12?
Yes.
Is 4 a factor of 12?
Yes.
So no, notice I'm going through all the numbers. Is 5 a factor of 12?
No.
No, so I don't display it. Is 6 a factor of 12? Yes, so I display it. Is 7 a factor of 12? No. Is 8 a factor of 12? Is 9 a factor of 12? Is 10 a factor of 12? Is 11 a factor of 12? Is 12 a factor of 12?
Yes.
Yes, so I display it. Thank you, God said. Appreciate your participation. All right, so does that make sense? Now it's just a matter of coding that up. So we know that we're going from this number to this number. Now, if the number was always 12, we could just, in order, go from 1 to 12. But we don't know that. This is just an example. This could be 100. The 12n could be 100. Right? So then we have to go 1 to 100. So that's why we use a loop, right? So we know how many times we're going to do it. We're going to do it n times. So we start by writing our for loop. So for int I. So we're going to say, let's say I is going to go from here, and it's going to take on all these values and then go to here. So that's the start value, and that's your stop value. Right. So this is our start value, so I should be?
1.
Okay, Sumaya, tell me what the next thing is. I should be? When do I stop? Less than? Or equal to? Don't forget equal to, because we do want to include that one.
Sir, I don't
So
think
we
it's
say
the-
12, but what's 12 representing?
And
N. Good. So now we can put the variables back in, because remember, this is where you go back and forth between your example and your
I don't
variable.
think that's a semicolon.
And, oh yeah, that should be a semicolon. And then, what do I do next? How much am I increasing by each time?
One.
Got 10?
One.
So this should be
I plus this.
I. I plus plus. Why is it doing that? Oh no. Okay, so now inside the loop. So the inside the loop is what did I do? So the loop structure was there to set up going to each number. After I go to each number, so I go to the first number, what did I ask? What was the question?
Is it a factor?
Is it a factor of 12? So how do I ask that in code? Well, how do I ask a question, first of all? Lillian? How do I ask a question in programming? How do I ask it? I just put a question mark? No? What's the statement that I use?
It's the local.
Which one? Yeah, if. Exactly. If. That's how we ask a question. So we know we need an if statement because we were asking a question. Is 1 a factor? Is 2 a factor? So here I'm just going to write pseudocode. Remember we talked about pseudocode before?
Yeah.
Pseudocode like this fake code. We don't really know. It's just kind of like English, right? So just get the main steps out. So if I, what's the question I want to ask? I is going to be all of these numbers. If I is a factor of 12, and 12 is n, right? So if I is a factor of n. Again, this is pseudocode. I can't write this in real code, right? So pseudocode is something that lists out all your steps for you, so you can keep the steps straight without getting washed away in the details. And this is why we do this first. This is why we develop pseudocode first on a piece of paper, so we don't get. Notice I didn't write scanner up here, and I don't have to worry about my import line. When you're trying to do everything at once, it's overwhelming. Programming becomes overwhelming. So here I'm just tackling the problem without the scanner and how to even do this line. And we'll worry about that part later. But at least I can get the main steps here. So if I is a factor of n, what do I want to do? So we went through 1, because this is going to go through 1, then 2, then 3. We want to display it. Good. So we can say display, or we can just say print I. Now again, that's not real code, right? What's the real code? System.out.println. But here's another reason why pseudocode is useful. Pseudocode is useful because I can give this to any programmer in any language. I can give it to Ben. Ben likes programming in Python, so he can figure that out in Python, right? I can give it to Lucas, and Lucas likes programming in C. He can figure out the commands for printing in C, right? You can give the pseudocode to people in different languages, and they can do it. Also, did you know that programming is one of the most outsourced jobs ever? They find that programmers are cheaper to hire in other countries. There's a lot of programmers, for example, in different countries. So, what you'll get your job for here and keep your job is being able to develop solutions. And once you develop the solutions and the pseudocode and the design of your program, you can hand that off to somebody else and they can program it. This is the hard part, right? So you got to get good at doing the hard part and solving the problem. So we print I, and that's it. Else, do I need an else statement?
No.
Hey, Mr. Smith. Come on in. Okay, so we print I. Do I need an else statement here?
No.
No, right? Because else do nothing. It's only want to print it if it is a factor. So that's pretty much it, right? That's pretty much it. That's your code. Now we code this up. So let's go code it up in our program. And now it should be a lot easier to code up. Oops, I already have one. Okay, so I'm going to go file new. Dr. Java. Okay, so I'm just going to copy and paste this stuff in here to save some time. Let's not call it quiz question though. Let's call it display factors. Okay, so we can code this up. We've got our scanner already there. Int n. Okay, so let's take that out. Close that and close that. And so now I'm going to write my for loop, right? I've got my input. I might want to say here before actually system.out.println. What did I say in the question? Please enter an int. I like copying and pasting from the question itself, so that way I know that I'm not changing anything. I'm doing exactly the way Cardoso asked me to do it, but I didn't copy and paste it there. Okay, so int I, let's look at my, where is it? I equals 1, so I have the pseudocode, right? Go ahead, God send.
So I less than equal to n semicolon application.
Right, so I open and close. Now, we get to the hard part that we didn't do. So I can't write if I is a factor of n, if I is a factor of n. That's our pseudocode. And pseudocode also works its way into comments. Right? Pseudocode also works its way into comments. When you're coding, sometimes you do end up coding without pseudocode, but that's where you can use your comments to kind of help you. What am I going to do next? Write it in a comment, then do it. What am I going to do next? Write it in a comment, then do it. So comments help you know what you're trying to do. Sometimes you lose track of what you're trying to do. Okay, so the if statement here. How do I know if I is a factor of n? God said.
So if n mod I equals 0.
So if n mod I equals 0. So we want to see if I is a factor of n. So we use modulo. If the remainder, because remember, this gives you the remainder of division. So if you're having trouble with that, break it down into numbers. Victoria? Perfect. Yeah, we'll get to that. But yes, excellent. So here we go, n mod I equals 0. Right? Now, if you're having trouble with this, think about it. Substitute the numbers in. Right? From our example. So n is 12 from our example. I is 1 at the beginning. So 12 mod 1, what is that? 0. 12 mod 1 is 0. The remainder is 0 because 1 goes into 12. And we know 1 is a factor. 12 mod 2, when we go to the next one, is 12 mod 3 is 0. 12 mod 4 is 0. 12 mod 5 is 2. Because 5 doesn't go into 12. Right? 5 times 2 gives you 10 with 2 left over. 12 minus 10 gives you 2. So that's not a factor. 12 mod 6, 0. Right? 12 mod 7. There's 5 left over, right? 12 mod 8, 4. 12 mod 9, 3. Right? So none of these are factors. 12 mod 12 is 0, because 12 goes into 12 exactly with 0 left over. So everybody understand this? Okay. So that's really useful. Now, what do we do? System. And we just say I, right? We need to print out I, because I is the factor that we want to print out, the current factor. So then we have that here, print I, right? So we're just taking our pseudocode, and it's much easier. And that's it. Okay, so let's compile that. You're going to have to save it. You want to save it in ICS3U, PM, display factors. So now it's available on Brightspace for you to download. Alright, so let's run it. Oh, I didn't compile it. Oh, let me change my compiler down to Eclipse. If you are using Dr. Java, you have to change that compiler down there to Eclipse. Don't worry about that. Okay, so I put 12, and I get 1, 2, 3, 4, 6, 12. Woohoo! Run it again. Let's put 20. 1, 2, 4, 5, 10, 20. So check your answers. Don't be satisfied with just one test. Let's put 5. We get 1 and 5. It's a prime number. Okay, so we've done a few tests. Now, let's take it to our visualizer, because we want to analyze this a bit further. So remember the visualizer. So whether it's working, so our program happens to be working, but even if it's not working, especially if it's not working, that's where you want to go to your Java visualizer.
Will the visualizer work?
Well, it has to compile.
Yeah.
So make sure your program compiles. But oftentimes it would compile but still not work, like it's not giving you the right answer.
Like a logical error.
A logical error, exactly. So that's where you use the visualizer. Now, can I use the scanner in the visualizer? No. So what should I do? Hard code a value in. So I'm not going to read this in from the user. I'm going to say this is 12. Now, this is part of the skill. The first skill that I showed you was using a piece of paper, developing an algorithm, developing pseudocode, right? That's the first question. If you ask me for help in the lab, I'm like, show me your pseudocode on a piece of paper. Did you work it out? Did you work something out? Did you draw something? Did you even scribble on a piece of paper? Right? That means, you didn't put that effort. So that's the piece of paper. The second part is actually using the Java visualizer to help you as much as possible. So, even though this is an easier example, much easier than the lab, the skills that you're learning here on how to use the visualizer. So, I click visualize here, I hard-coded a value in, just as an example. Now it says, how many steps do I have here? 47. Okay, keep that in mind for later. Now, how many people, when they've used the visualizer, you can be honest, I've done this before. How many people just do this? How many people just do this? I'm just clicking forward. How many people just do that? Have you done that before? Are you guilty of that once in a while? Okay, so I'm guilty of it too. I'm going to go back to first. Now, I don't want you to use the visualizer like that. You can use it in between, here and there, but I want you to strategically think, how should I use the visualizer slowly and methodically at certain points to understand exactly what's going on. Alright, now, so n is 12. So at least at the beginning of the loop, you want to go through it slowly. And the end of the loop, you want to go through it slowly. And this is kind of like trace tables. Choose values that it's not too big, too long. If I choose 100, I'm going to be clicking forever, right? So that's why I chose a number like 12. So I can actually go through most of it. Now, so that's one thing.
Wait, actually, sir.
Yeah.
It's not really relevant, but like, do you even need to save 12? Can't you just put 12 into the zero condition?
Into here?
Into like the 4I is less than 12. Can't you do that and just not save it?
Yeah, I can do that, but now it's just easier because I've got n here twice, right? Okay, so now, so you want to choose a value, and at least at the beginning of the loop and at the end of the loop, you want to go through it slowly, and then strategically at certain points inside the loop. So where should I go? Okay, ready? So I go forward. Now notice that it gives me 12 here, so I can do my substitution for n. I is 1. So now, this happens only once. Is I less than or equal to n? It goes here first, right? So it goes 1, do the substitution. Is 1 less than or equal to 12? Yes. So we go inside, we don't do this. Remember that happens at the end of the loop. We go inside. Then we say n mod I equals 0. Is it? Is 12 mod 1 equals 0? Yes, it is. Sorry. And so then we go inside, and it's showing you that it goes inside. And then it prints that out.
Well, where does it show it goes inside?
Because this was highlighted.
Oh.
And you can see the output down here. Right? And so this says down here, this is the line that just executed. This is the next line to execute. So now we know after that, it's going to come up here. Now, this one's confusing because it's like, does it execute this whole line? No. It just executes this part of it. Right? I++. So I change this to 2. Now, if you're having trouble, this is another debugging technique. So again, you might not have trouble with this particular example, but this is a skill that I'm showing you. Ready? If you're having trouble with this line of code, show more work. You know how your math teacher always says, show your work? Now I'm saying show more work. We're not seeing enough of the inner parts here. Let's go back to edit the code. What more work can we show? If I do this, you watching closely? if I go int remainder is equal to n mod I. So if you're not getting the right answer, show more work. So I put that now into a variable. What does putting it into a variable help you?
You can see the remainder.
You can see what it is. So now I can see what it is. So if you're debugging your code, because remember your lab's going to be hard. So if you're working through your code and it's not working, show more work. Take things that you weren't, putting in variables and stuff like that. Put it into a variable so you can see it. Watch the difference now. Now I go in here, I have 59 steps instead of 47. But that's okay. Yeah, so like we want to see what's happening, and sometimes again, imagine your program. Our program's working, like we tested it, right? But imagine our program wasn't working, and we didn't know what the problem was. What I'm trying to get you to do is not say, Mr. Cardoso, my program's not working. Right? I want you to do the hard work that I'm showing you how to do now. Show the work. Put that line in. Trace through it. Find the error yourself. Right? Why do we do the hurdle? Why do we not look the answer up? What's the point, right? If I'm doing it for you, you're not learning. You have to do this. This is your learning process of problem solving. All right, so now we've got more steps here, but that's okay. We're going to see that result come up. Watch the difference now. So now we got 12 and 1 again, and now we got this variable remainder. So remainder pops up, and it goes 12 mod I is equal to 0. Is 0 equal to 0? Yes. So we print it out. Boom, prints out. Now I change this to 2. Notice how the variable remainder disappears too, right? Because it's only valid inside the loop. So, and every time we kind of redeclare it. So, remainder comes up. 12 mod 2 is 0 as well. 0 is equal to 0, so we print it. Then we can skip forward. Now, which number should I skip forward to? I might get lazy here and skip forward a little bit, save time.
Skip to 5.
Maybe I'll skip to 5. Why 5?
Because the remainder is 2.
Yeah, because we know 5 is not a factor. So let's skip to 5 and see what happens there. So this is how you want to use your visualizer strategically. So 5 is not a factor. Let's see. So n mod I. So 12 mod 5 should give us a remainder of 2. 2 is not equal to 0. So therefore, does it go inside? No, it skipped it and didn't print. And so we analyze that. Now we can go 6. Okay, 6 is a factor again. It's 0, so 6 should print out. And 6 prints out. Now it changes to 7. 7. Is 7 a factor? No. In fact, the remainder is 5. 5 is not equal to 0. Is 8 a factor? No. Remainder is 4. Remainder is 3. Remainder is 2. Remainder is 1. Now 12 mod 12. The remainder is 0. It is a factor. Does go and print it. And we get the 12 down here. And then we finish. And we're done. So, yes, okay, it can be time consuming. Yes, it can be work. But yeah, programming is sometimes, especially when we get to loops, it gets a little bit more challenging. You have to spend the time doing this. Practice doing it now. Because on your quiz, your next quiz, you're going to have one problem. One problem where you're going to have to, trace through everything and program it all by yourself. And, so it's going to be more of a high-stress situation. So practice using this so you know how to solve it. Yep.
Is the programming test in the next one?
The next one's a programming one, yeah.
Okay, you got finished.
All right, so now it's done. But remember, if I go back to first year, it tells me I had 59 steps.
Exactly 12 months.
Now, for grade 12s, I'm more marking their efficiency. Right? Grade 11s, I'm not going to be marking it for these kinds of adjustments. But let's just analyze it for a second here, just so that you can start practicing for next year and also learning how to use the visualizer and stuff like that. So, we know that none of these can be factors, right? Can any of these be factors?
Which one?
7, 8, 9, 10, 11.
No.
Can they be factors of 12?
You can't divide the numbers past the halfway point.
No, it's past the halfway point. Now, if our number was 100, let's say our number was 100, right? We'd have to go from 1 to 50 to 100. And we'd be checking from 51 to 99, even though none of those could be factors. If our number was 500 to 1,000, If our number was 1,000, we would be doing 500 kind of extra steps. So, this is what Victoria suggested as well. Instead of going to n, let's go to the halfway point, because we know after the halfway point there are no factors, right? So we go over here, we go edit code, and so now we're going to go to n over 2 instead of n. Now what if n was an odd number? So let's say n was 13. What would 13 divided by 2 be? It would be 6. Why? Because of integer division. So it'd still be 6, and that's fine. 7 would not be a factor of 13 anyway.
Sir, I think you chose a prime number. Okay.
So, and yeah, that's a prime number. But 7 we know, 7 wouldn't be a factor. So that's okay. It would still work for odd numbers. So think about that when you're doing this kind of thing. So I'm going to go to n over 2. Does the program still work?
Well,
Now you, Victoria. So now, by the way, how many steps did I have before? 59 after this adjustment. So now I went from 59 to 34. That's however many less steps that the processor has to do.
yeah.
And however many less forwards you have to click to get to the end. So every time you're clicking this button, the processor has to do something. So that's, way less work. Now, does the program still work? So here, it goes forward. Now I can click a little faster. It's going to 6. It's going to stop at 6. What's the problem?
How do you get the 12? How do you get the final value?
Yeah, it's not printing the final 12, is it?
What is out of print n?
Exactly. So that we just have to do one time after the loop. So the loop, you can see it's opening and closing here. The loop is ending there. I can't stress enough when you're doing programs with lots of things inside other things. Like here I've got an if statement inside of a loop. Make sure, all of your brackets match up. So many errors are caused by that. Indentation. Poor indentation causes errors. Even though indentation doesn't matter to Java, it matters to you, and you get disorganized and you don't know where your code is. So now I'm out here, and I just want to print out n. Whatever n is, I'll print it out. Because I know I'm not going all the way to n, so that's just one extra step. Instead of doing everything from 7 to 11, I stop at 6, and then just print out 12 at the end. Save the steps. So now I visualize, and I have 35 steps instead of 59. Now let's just click last. You can see the program here is working. Gets the 12 now at the end. Make sense? Now, that might not seem like a big deal, but let's say n was 100. Now, if I had n was 100 and I go to n and I take this out, which is what the code was before, how many steps is that? So this is what the code was like before when I went all the way to n. It is 414 steps.
Okay.
Now let's edit that. So that's 414 steps when n is 100. Let's change that to n over 2. Add that one line back in. And we're down to 214 from 414. So not exactly half because of all the other things that we still had to do. And we had to add this step. So this is what we were talking about in terms of the algorithm efficiency with the grade 12s as well. We were saying before we had O of n algorithm efficiency. Now we have O of n over 2 algorithm efficiency. Now technically, because we had to add this one step, right? So technically it's not O of n over 2, it's O of n over 2 plus 1 for that one step that we had to add there. On your quiz yesterday, you noticed that there was a little adjustment that I did at the bottom after the loop. Right. So I made it more efficient. I did an n over 2 thing and I added something at the bottom. So hopefully you traced that out and you saw that. So I did that efficiency thing where you have to do like one slight adjustment. But the n over 2 plus 1, the plus 1, who cares about the plus 1? The plus 1 is not going to make a difference when I change this to 1,000 or when I change this to 1,000,000. That plus 1 step is not going to make a difference. But the n over 2 makes a huge difference from the n. Anyway, that's talk about algorithm efficiency, which you don't seriously have to worry about in grade 11. It's something more that I focus on in grade 12. But it's good to practice as well and seeing how to use the visualizer. Any questions about this problem, how we did it from beginning to end? how we solved it. Okay, so just to review, you want to try to solve your problem on a piece of paper, try to develop some pseudocode, try to see what you need to do, code it up, even if it's wrong and it's not giving you the desired results, take it to the visualizer little by little and work through, why is this not giving me the results? Have your piece of paper there with the visualizer, try to work it out step by step, okay, slowly but surely, and then you'll fix it. The only way to fix problems in your program is to know what the problem is in the first place. If you don't know what the problem is, you're not going to be able to solve it. So the visualizer will help you do that. Also practice not being able to use the visualizer. For now you can use the visualizer. On your quiz you'll be able to use the visualizer. But when you go to university and you're trying to do these problems, they won't always allow you to use the visualizer to solve your problem. So it's also practice, if I was doing this on paper and tracing it on paper, would I be able to figure this out? Alright, that is your lesson for today. Now, the next problem is, if I go back over here, your next problem is prime number. It's very similar to the problem we just did. So practice. Try to do this prime number example using the visualizer, using a piece of paper. It's very similar. You can even download this program that we've done. It's already on the bright space on the correct icon. So download it and try to write the prime number problem using the tools and the visualizer and everything that we've done here. Try to solve it on your own, and then you can take that one up tomorrow. Question? Sure. All right, let me stop recording.